What's up, everybody, and welcome back to another math puzzle. In this one, the question is as follows. Find the value of x if the area of the green triangle is 6 feet squared more than the purple triangle. So here's the green, here's the purple. And once again, notice that this is a trapezoid and that these are two right angles. Hit that pause button and see if you can figure it out. When you're ready, hit play and I'll give you the explanation. So this question right here is pretty darn difficult, and there's a lot of variables that we're gonna have to write in, and we're also gonna have to recognize something about this green triangle and this purple triangle. So let's look at that first. So you notice that we have these two right angles there and there, and that means that these two lines right here are perpendicular. What that also means is that if you have this nice transversal connecting those two parallel lines, we know that alternate interior angles must be congruent. We also know that vertical angles up here must also be congruent. And what that means is that these two triangles therefore are similar, aka proportional. So that's going to be very important to this puzzle. Now the next thing I'm going to do is draw in this height, and this is going to be a height both for the purple and for the green triangle. And the reason why this is going to be helpful is because it's talking about a relationship of the areas. So to get area of a triangle, again, we need 1/2 base times height. Now the fact that these two triangles are similar is very important because we can start to derive some really cool relationships, right? So for example, if we know that this is the base of the purple triangle, we can see that for the base of the green triangle, we could call it a different variable. We could call it D, C, whatever we want. But the nice thing for similar triangles is that there's some constant that when we multiply it by whatever side length of the purple triangle, we'll get the side length of the green. So let's call that constant C. And the cool thing is this constant will be the same constant that will multiply from the height of this one to get the height of this one. So the reason why that's great is now I can call this one a height of H and this one a height of CH, again using that same constant of proportionality. The last thing I'm going to do is I'm going to draw this same line down right there, and the reason why that is beneficial is because this is going to make a right triangle here with the X, and that X is now the hypotenuse of that right triangle. Okay, now let's start establishing some equations that showcase these relationships that have been described up here. So for example, how do we get the area of the green triangle? Once again, it's 1/2 base, which is C times B, times the height, which is C times H. And they're saying this is 6 more than the height of the area of the purple triangle. What's the area of the purple triangle? 1/2 base times height. So we got a B and an H like so. Now before we go forward, I want to simplify this equation a little bit. So I'm going to multiply everything by 2 to get rid of the 1/2, and then I'll also combine these guys. C times C is C squared. So we now have C squared times BH equals 2 times 6 is 12 plus BH. And we're going to simplify this a little bit further. Okay, there's going to be a lot of equations here, so we got to make sure we're careful with the room. So I'm going to subtract BH to the other side. So we now got C squared times BH minus BH equals 12. And then I'm going to factor out the BH. So now we have BH times C squared minus 1 equals 12. Last but not least, I'm going to factor that difference of squares. So I'm going to say BH C plus 1 C minus 1, and this all equals 12. So that's a pretty cool equation. Now, the next equation you might not think to make because it's almost too obvious, which is that H plus CH equals something. And what does it equal? It equals this full height of 3. So I'm going to write that out. So we've got CH plus H equals 3. Now you might not see anything super special here yet, but if we factor the H out here as well, we get C plus 1 equaling 3. So now what you might notice is, check it out, we got H times C plus 1, we got H times C plus 1 here as well. So now we can do a little substitution and substitute that 3 in. So we're going to take this little spot up here. So we've got B times, instead of H times C plus 1, we got 3. And then we've got C minus 1, and this equals 12. I know this looks messy, but the next thing I'm going to do is I'm going to divide both sides by 3, and we've got B times C minus 1 equals 4. Now, you might not think that this is significant either, but there's something really interesting going on. Now we're going to go back to this right triangle that we had identified at the beginning. And again, right triangles are great because we can use Pythagorean's theorem to identify missing sides. So we already know that this long side here is 3 because it matches with this length given there. We know that this is x, which is the hypotenuse, which is what we're solving for. What we don't know is this length, but we can represent it with these two guys, right? Because this length is the full CB minus the B up top, right? Minusing this length, and then we're left with this length. So therefore it's CB minus B, but guess what? We can factor once again. We factor out the B and we get C minus 1. And so this length here is B times C minus 1, which we already know is 4. Okay, so that means for this right triangle, we've got a side length of 3. We've got a side length of 4. By the way, this is not drawn to scale, so excuse me there. But the fact now that we have 2 legs, 3 and 4, we can find the hypotenuse by using Pythagorean's theorem. But I'm going to shortcut it because this is one of the most famous Pythagorean triples out there, the famous 3, 4, 5 right triangle, which means that x must be equal to 5 feet. That's how you do it. Done. I hope you guys enjoyed this math puzzle, and if you did, please click that like button. If you want to see more math puzzles on the regular, make sure to click subscribe. Thank you guys so much for joining. I'll see you in the next video. Take it easy.